Hello and welcome to Module 2. In Module 2, we'll be talking about environmental indicators and their trends and sustainability and how it's measured. To start off, I'd like for you to take a look at these two vocabulary words. I'm not going to show you all the vocabulary words as we go through, but I want you to recognize that these are important ones. And in ecosystem service is the process of which life-supporting resources such as clean water, timber, fisheries, and agricultural crops are produced. So we'll talk a lot about an ecosystem and their ecosystem services, and that's important to know. And on the next page, there's a really great chart that we'll talk about that is an environmental indicator is something that indicates the health of a system. So here's this chart. This is the chart of the 5 global indicators that we're going to be talking about. Environmental indicators help us to describe the current state of an environmental system. In this book, we're going to be talking about these 5 global scale environmental indicators, and those are biological diversity, food production, average global surface temperature and carbon dioxide concentration, human population, and resource depletion. And honestly, this would pretty much sums up the course. We're going to be talking about those 5 things quite a bit. These are things that will tell us what we might need to look at more deeply into a particular issue. Okay, the first one is biodiversity. So this is the first global indicator is biodiversity. There are 3 different scales to measure biodiversity. There's genetic diversity, species diversity, and ecosystem diversity. So population with high genetic diversity are able to respond to environmental changes better. So these are pretty good pictures here. You can see that this has genetic diversity. So these 3 squirrels are actually very different in their genes. And so that would mean if there was some disturbance in their environment, maybe it would only affect one of the genetic makeups, but not the others. And so they would be able to reproduce and recover from that disturbance. And then high species diversity, this is the picture of species diversity here, means that there's lots of different kinds of animals. We're not just talking about the squirrels here, we're talking about the squirrels and the woodpecker and the mushrooms and the plants and the giant bear. These ecosystems are more productive and they're more resilient, so they're more able to recover from disturbances. And then finally, ecosystem diversity, which actually we're going to talk about on the next page. An ecosystem, so the greater number of healthy ecosystems in an environment would be a healthier overall. So let's look again. You can see there are several different ecosystems. There's this high elevation ecosystem, ocean, shoreline, kind of an intermediate area, and then there's some desert over here. So these are lots of different healthy ecosystems. So you have lots of different healthy ecosystems leads to better overall environmental health. Another thing that this chapter talks a lot about is extinction rate, and that's something that we'll continue to talk about in the class. Our extinction rate now is much higher than it's ever been, and it's something that we need to consider as we make changes in our environment. And we need to know what is an acceptable extinction rate and what is not acceptable. Okay, let's take a moment to look at this math situation. The math that's in this textbook is really helpful to stop and take a look at. Remember that you will not be allowed to use a calculator on the exam, so everything should be able to be done without. So in the metric system, land area is expressed in hectares. A hectare, abbreviated HA, is 100 meters by 100 meters. So I'm going to write this down. I've already started to save a little time. In the United States, land area is most commonly expressed in acres. There are 2.47 acres in 1 hectare. However, I went ahead and changed that to 2.5 because we are going to be doing this by in our heads, you know? It's relatively easy to do without a calculator. Rounding it to 2 significant figures is 2.5 in 1 hectare. So 100 hectares times 2.5 acres would give you 250 acres. So now let's look at this one. A particular forest is 10,000 acres, and how big is it in hectares? Well, if you've ever taken science with me before, you know that my favorite thing to do is given times line. So our given here is 10,000 acres. So we have 10,000 acres given times line. I want to get this acres into hectares. So how can I change this to hectares? I could get rid of acres this way, and I want this to be hectares here, and that way I would end up. So I just follow the units. Acres, acres, hectares, hectares, right? So now how can I multiply this by 1 here? This needs to equal 1. Well, I could just say 1 hectare is equal to 2.5 acres, right? So then all we're really doing is dividing 10,000 acres by 2.5, and that just gives us 4,000. 4,000 hectares, right? So pretty easy. Remember my given times line and follow the units through. On the exam, while we're talking about math, it's important that you always show your work. That way I and any readers on the AP exam can give you partial credit if you deserve that. Okay, food production is the second indicator that we're going to be talking about. Food production is our ability to grow food to nourish the human population. In the past, we've used science and technology to increase the amount of food that we can produce. But notice, here's our food production over time. Notice it's really been leveling off since, I don't know, about the 90s. It's starting to really level off. So that is indicating that our science and technology has really peaked in the area of food production, and we're starting to level off in the amount of food that we can produce. All right, the third global indicator is the surface temperature and carbon dioxide concentration. Know this graph. This is really important. This shows the global temperature in degrees Celsius and the carbon dioxide in parts per million and the year. So you can see that both have really gone up, and it appears clearly that the carbon dioxide and the global temperature are highly related. One of the reasons why our temperature has been going up is because of the greenhouse effect. The greenhouse effect can be a little bit challenging to understand, and we will be going over it again in more detail in chapter 4. But what is important to understand is simply that the greenhouse gases get trapped and they make heat kind of bounce back to the earth rather than just being dissipated into the environment. An important word to know is anthropogenic. Anthropogenic means derived from human activities. So the question arises is extra greenhouse gases in the environment, are they anthropogenic? Is the extra carbon dioxide that's going into the atmosphere anthropogenic? And that is a question everyone's asking. Most people think yes. We'll continue to talk about that. All right, the fourth indicator would be human population. Our current population is 7.2 billion, and it's estimated that in 2050, there will be about 8.1 to 9.6 billion people. So you guys will be around for that, and you'll see this. And then in 2100, it's supposed to kind of level off here and stabilize a little bit, and it'll still be increasing, but not by as much. So we're estimating 7.1 to 10.5 billion humans on the planet. So can our planet sustain that? We don't know. We will find out. The fifth indicator is going to be resource depletion. So as the human population goes up, the demand on Earth's resources also goes up. That seems pretty clear. One of the things that we need to consider, oh, did I go? Nope. Is the poorest 20% of the world, they only consume about 5% or less of the resources. So it's the most developed nations, like our country, that are really consuming the majority of the resources. So it's something as less developed countries become more technologically advanced and have more resources available to them, how is that going to influence the Earth? Easter Island is so interesting. It's also called Rapa Nui, the island. It was abandoned a long time ago, and there's a few questions as to why it was abandoned. They did these really big, beautiful, strange statues, and so they've led to a lot of questions. There are two theories right now. One of the theories is that the community was not sustainable because there was so much deforestation that they wiped out all of the trees in order to build these giant statues, and that led to famine and war. Another theory is that there was invasive rats and disease that wiped out the food supply, so they were actually able to live sustainably until European sailors brought this disease, and also brought the slave trade. We'll never really know what happened, but it is something that we're going to continue to look at because it's just a great study of sustainability. Sustainable living. I really like this sentence here. Living sustainably means acting in a way such that activities that are crucial to human society can continue. So that's the definition of living sustainably, and it's something that we're all striving for and studying what that really means to our communities and ourselves as well. Okay, when we talk about defining human needs, what are our human needs? Well, we might say Wi-Fi and electricity and new clothes and a car. Really, our human needs, though, are air, water, food, and shelter, right? So let's make sure that we keep this in perspective as we continue. I love this word, biophilia. It's the love of life. So biophilia is this paragraph talks about how human needs, these are the human needs. However, there is a human connection that people desire and maybe need in order to have a happy life, and that is part of biophilia. Okay, I would like for each of you to take this little quiz. It just takes a moment. So go to earthday.org/takeaction/footprint calculator, and you can figure out how many planet Earths we would need if everybody lived like you do. I think that I live fairly sustainably. I try to anyways. But if everyone lived like me, we would need 4.5 planet Earths to provide enough resources. So that's a little bit daunting. So the ecological footprint, it's a measure of how people consume and how much land it would take up in order to live. How much land so I personally am taking up in order to live. All right, did we go through these two things? Environmental indicators, we did, and we will continue to as the class goes on, and sustainability and how it's measured.